Greetings and welcome back. First of all, I want to again congratulate you for coming this far and finishing the first two passages well. And now we are about to begin the third passage. If you've noticed, the first two passages, the first one we worked on was the world literature passage, and the second one was a social science. This third one is a science passage, and I want you to know that the science passages are generally shorter than all the other ones. So if you look at this one, for instance, you'll notice that we only have about 51 lines, which is good news. So for that reason, we will not be chunking this one, because 50 lines is right about where we would be stopping had we had more lines. Like the first passage, we had 95 lines. We chunked right around 65. So since we only have 50 lines, we can get by just reading all the way through and answering all the questions. So without further ado, let's begin. And bear in mind, we are using those 4 reading strategies, which are to read the excerpt, skim and annotate. We're going to skip over chunking, but we will be using the My Answer strategy, where you come up with your own solution. When you read a question, before looking at those 4 choices, come up with your own answer and see if your answer matches any of those 4. We are learning that if you do that, and you find the answer that you have in your brain as one of those 4 choices, you have a 99.9% chance of being right. And 2 more quick notes. One is about the reading the excerpt. Just want to remind you once again that when you're reading the excerpt, we found out we don't care about the author's name. We don't care about the publishing company's name, nor the year that they published the article. What we care about are there any characters, or is there any pertinent information from that passage? Second note, when we are annotating, don't focus so much on how I'm actually annotating. Focus on what it is that we should be annotating. What should we be looking for? And as a quick reminder, you want to look for main ideas, any recurring themes, any definitions, especially on science passages. There's going to be a lot of definitions of scientific terms and processes. We're going to look for cause and effect and that sort of thing. So just follow along. This passage is adapted from J.D. Watson and F.H. Crick. So again, we don't care about the name of the author. And the title of this article is Genetical Implications of the Structure of Deoxyribonucleic Acid. 1953, published by this group. We don't care about that group. So we care about the title, which is Genetical Implications of the Structure of DNA. Deoxyribonucleic acid is DNA. So Watson and Crick deduced the structure of DNA using evidence from Rosalind Franklin, Gosling, and Chargaff. So what it sounds like from this first excerpt is that we have 2 scientists that are adding on to prior work done by other scientists. And I believe that's enough for us to actually go ahead and read this passage. So let's go for it, beginning with the chemical formula. The chemical formula of DNA is now well established. The molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate groups. To each sugar is attached a nitrogenous base, which can be of 4 different types. 2 of the possible bases, adenine and guanine, are purines, and the other 2, thymine and cytosine, are pyrimidines. So it sounds like there's a pretty good amount of information that we might want to annotate here. Let's go over it real quick. So we are understanding that the molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate. So there's an alternation of sugars and phosphate groups. So I think keeping in line with what I was showing you on the previous passages is you don't have to have long drawn out sentences. So this to me is indicating that there is sugar and phosphate groups that are alternating. Go on, to each sugar is attached a nitrogenous base, which can be of 4 different types. So the sugars have nitrogenous bases, and there's 4 different kinds of them is what they're saying. So, and the types of bases are adenine and guanine, and those are known as purines. So I guess adenine and guanine, and these 2 are known as purines. And then there's another pairing, which was thymine and cytosine. Thymine and cytosine, and these are defined as pyrimidines. Let's keep going. So far as is known, the sequence of bases along the chain is irregular. The monomer unit consisting of a phosphate, sugar, and base is known as a nucleotide. So that's the thing that we might want to annotate here, is the definition of the word nucleotide. I'm just going to write the word nucleotide here just in case there's a question about the nucleotide. We'll know where to go find it. Let's read on. The first feature of our structure, which is of biological interest, is that it consists not of one chain, but of two. Here, I want to pause and annotate real quickly because this passage is telling us that something is of biological interest. So here, I'm going to put interest. What we are learning is the first feature of our structure, which is of biological interest, is that it contains not of one chain, but of two. So maybe we're getting to the crux of the matter here. What's interesting to these two scientists is that there's not one chain, but there are two. Let's read on. These two chains are both coiled around a common fiber axis. It has often been assumed that since there was only one chain in a chemical formula, there would only be one in the structural unit. However, the density taken with the X-ray evidence suggests very strongly that there are two. Remember what we were saying, if there's any supporting evidence, that's something that you might want to annotate. And it sounds like these people are saying prior to this, we always thought that there was only one chain in the chemical formula. But this, however, is showing a change in thought. And it says that the density taken with the X-ray evidence suggests very strongly that there are two. So here's their evidence that something is changing. These are scientists and they're providing evidence. That's what scientists do. So this is something that you might want to keep an eye on and annotate for sure. Let's go on. The other biological important feature is the manner in which the two chains are held together. So there's something else in here that's important. How the chains are held together. This is done by hydrogen bonds between the bases. So this is about bonding. We can write about bonding. We can annotate the word bonding. And it goes on to say that this is done by hydrogen bonds between the bases. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a base from another. All right. The important point, then again, it's indicating to us what is important right here. So I'm going to highlight that as well. The important point is that only certain pairs of bases will fit into the structure. Only certain pairs fit into the structure. One member of a pair must be a purine and the other a pyrimidine in order to bridge between the two chains. Okay, so that's important. We are told that a purine and a pyrimidine have to bond with one another. So we can say a purine has to bond to a pyrimidine. And we don't have to write the whole word out, just so we know where to go find it. And he goes on to say, if a pair consisted of two purines, for example, there would not be room for it. So again, this is just emphasizing if you have two purines, so basically if you have a purine trying to bond to a purine, it would not work because there wouldn't be any space for that. In other words, the purines would be too big. So we go on. We believe that the bases will be present almost entirely in their most probable forms. If this is true, the conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine with thymine and guanine with cytosine. So adenine has to pair with thymine. That's a fact. They give us this over here. That's what they're thinking. And guanine with cytosine. So guanine has to pair with cytosine. Adenine, for example, can occur on either chain, but when it does, its partner on the other chain must always be a thymine. Read on. So the phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of bases can fit into the structure. It follows that in a long molecule, many different permutations are possible, and it therefore seems likely that the precise sequence of bases is the code that carries the genetical information. That sounds like something instrumental here, because we have many different permutations that are possible as a result of having specific pairings. So because adenine can only pair with thymine and guanine can only pair with cytosine, that allows for many different permutations, which together they form code. So that's the annotation that we're going to do there for this, and that comes from this section. If there's a question about it, we know where to go look for it. Next, we read from if actual. If the actual order of the bases on one of the pair chains were given, one could write down the exact order of the bases on the other one because of the specific pairing. And that makes sense, because they're saying if you have A and you have G and you have T and you have C, well, we know on the opposite side, A can only go with T, G can only go with C, T can only go with A, and C can only go with G. So that's what they're saying here. If you know one side, if you know this one side, you can automatically figure out what's on the other side because there's a very specific pairing. And then it goes on to say, from thus one chain is, as it were, the complement of the other. Oh yes, these are complements. And it is this feature which suggests how the DNA molecule might duplicate itself. All right, and then we have the table here. Let's just take a moment to examine and see what it's talking about, which information is being provided by this table. We are noticing here we have a bunch of different organisms. We have maize, octopus, chicken, rat, so on and so forth. And here are the 4 bases. In fact, we should probably color code these just so it's going to be easier for us to know which go together. We've found out that adenine goes with thymine from the passage, right? And then we were told that guanine pairs with cytosine. So that's probably going to come in handy later on. Having read the whole passage, it is time for us to try answering these questions. Now, this time, I want to encourage you all to attempt the question. So as we read the question, I'm going to give you the opportunity to answer it. What's going to happen, there's going to be a little bubble that's going to pop up on the screen asking you if you would like to answer this question on your own. Now, of course, this is assuming you've already printed out a copy of this. If you can't print it out, maybe you have another open screen that you can actually read the passage and go back as needed. Let's get started. So question 22. The authors use the word backbone in line 3 and line 39 to indicate what? This is a vocabulary in context question, so you should try to answer this question on your own before continuing to see if you got the answer right. So let's go over the choices. Choice A says only very long chains of DNA can be taken from an organism with a spinal column. And that's really random. There was nothing in this passage about organisms being, or rather spinal columns being removed from any organism. So A, we can eliminate as the wrong answer. What about B? The main structure of a chain in a DNA molecule is composed of repeating units. Remember what we said about backbone. Backbone is the main thing, the thing that holds everything together, the central thing. So I like the word main structure here. Let's read on. Let's keep B open. Could be the answer. Let's read on to the other ones. C is a chain in a DNA molecule consists entirely of phosphate groups or of sugars. Backbone is not referring to that at all, so C does not make sense. Let's look at D. Nitrogenous bases form the main structure unit of DNA. Well, this one has main structure unit as well in it. So let's see, do the nitrogenous bases, are those the main backbone? I don't think that's what it's saying. It's saying the molecule is a very long chain. The molecule itself is a long chain, not the bases. So D would be incorrect because it gives the main structure to the bases, to the nitrogenous bases, whereas the passage said the molecule. So it's got to be B as in boy. Okay, so let's go to the next question, question 23. A student claims that nitrogenous bases pair randomly with one another. Which of the following statements in the passage contradicts the student's claim? So once again, I encourage you to just try this question on your own. Let's go ahead and answer it. Lines 5 through 6. So we're looking for contradicting evidence in this evidence-based question. That nitrogenous bases pair randomly with each other. We know that that's not true because we actually annotated that there has to be a very specific type of pairing, and that was in this region when he said a purine has to pair with the pyrimidine. Let's see if this region is one of the choices in here. It looks like 23 through 25 is actually featured, and that would have to be it because 27 through 29, well, these two are pretty close to one another, so we better read this more carefully. So 23 says, the bases are joined together in pairs. A single base from one chain being hydrogen bonded to a single base from the other. Well, that's not giving us any information on specific order, so I don't think 23 through 25 would be the answer. Let's read to the other part, where it's 27 through 29, which says one member of a pair must be a purine and the other a pyrimidine in order to bridge between the two chains. So that's got to be it. D would have to be the answer to this one. And there we have it. On to the next question, question 24. In the second paragraph, lines 12 through 19, what do the authors claim to be a feature of biological interest? This is a detail / little picture question, and I want to pause here and just again emphasize the importance of annotating and how cool it is when you really get good at annotating. We literally annotated biological interest. If you hear the passage prompting you something is important, well, you should perk up and pay attention to it. It did say biological importance somewhere around here. Yeah, we actually annotated this as interest, but here it is. The first feature of our structure, which is of biological interest, is that it consists not of one chain, but of two. So what they noted would be of interest in lines 12 through 19 was that the DNA would consist of two chains, not one chain. And that's clearly a choice here. A is not it, B is not it, C is not it, DNA consisting of two chains. All right, let's try the next one. The author's main purpose of including the information of X-ray evidence and density is to do what? Let's read that again. The author's main purpose for including information about X-ray evidence and density is to what? This is an author technique. Why did they include that information? What did it bring to this story? All right, so let's try to figure this out. Where was X-ray mentioned? Oh yeah, we actually annotated this. We annotated it as evidence right here. And the reason why that was brought up, let's start here. So these two chains are both coiled around a common fiber axis. It has often been assumed that since there was only one chain in the chemical formula, there would only be one in the structure unit. Now here's the however. This is indicating a change, a break from what was commonly understood. However, the density taken with X-ray evidence suggests very strongly that there were two. So the X-ray and the density is what actually proved that there were two chains and not one chain. Let's go to the choices and see if we can find that in there. Choice A, to establish that DNA is the molecule that carries the genetic information. No, that's not what the passage said. Present and alternate hypotheses about the composition of a nucleotide. Nope, that's not why the X-ray and the density was brought up. Provide support for the author's claim about the number of chains in a molecule of DNA. That was precisely it. 25 is C. And D does not make sense because confirm the relationship between the density of DNA and the known chemical formula. No, that's just random. So C would have to be it. And I'm hoping at this point in time you're really, really understanding that annotating will be a lifesaver for you. So let's go on. Let's read question 26. Based on the passage, the author's statement, if a pair consisted of two purines, for example, there would not be room for it. Lines 29 through 30 implies that a pair would what? All right, so lines 29 through 30, let's go there and see if we can find this. 25, 29 is over here. If a pair consisted of two purines, for example, there would not be room for it. And we said a purine and a pyrimidine has to go together, and a purine and a pyrimidine cannot. A purine and a purine cannot go together, so you can't have two of the same. And why did the author say that there would not be any room? If you don't have room, that means you're too big. You're bigger than the space provided. So let's look through the choices and see if there's anything that agrees with what we've already come up with using our my answer strategy. So the author is implying that a pair of purines would be larger than the space between sugar and phosphate groups. Is that true or false? We can leave A open for now. Let's look at B. Is the author trying to imply that a pair of purines would be larger than a pair consisting of a purine and a pyrimidine? Yes, this is what they're saying, because A is saying purines would be larger, which we agree with. We understand that to be the case. If you have a purine and a purine is too big, it will not fit in the space. And B is also saying the same thing, would be larger. The only difference between those two choices is A is saying the purines would be larger than a sugar and a phosphate group. And that doesn't make sense because purines are sugars. And the other one, part B, is saying the two purines would be bigger than a purine and a pyrimidine. Remember, the purine and the pyrimidine is the correct pairing. So if you do a purine and a purine, it's too large. So B would have to be the answer to this question. And that completes it. Let's go to question number 27. The authors use the words exact, specific, and complement in the final paragraph. Functions mainly to. So this is a function question. Why did the author use those words? Let's try again. The author's use of the words exact, specific, and complement in lines 47 through 49 in the final paragraph functions mainly to do what? So let's go to those words from the last paragraph over here. I'm going to highlight them so we can see them easier. 47 starts here. Write down the exact order of the bases on the other one because of the specific pairing. Thus, one chain is, as it were, the complement of the other, and it is this feature that suggests how the DNA molecule might duplicate itself. So we read more than we needed, but let's actually start here with if the actual order of the bases on one of the pair of chains were given, one would write down the exact order of the bases on the other one. So yeah, that's where the complement came in. In fact, we didn't annotate the word complement, but it's in here. Why do they use those words? Let's just go through the choices. We were trying to come up with my answer strategy here, but don't think that would be possible. So let's actually just read. To confirm that the nucleotide sequences are known for most molecules of DNA. Is that why they used exact, specific, and complement? Well, let's leave that open for a moment. Let's go to B. Counter the claim that the sequence of bases along the chain can occur in any order. Let's leave that open too. Support the claim that the phosphate sugar backbone of the author's model is completely irregular. And D is emphasize how one chain of DNA may serve as a template to be copied during the DNA replication. That's it. D is what shows up in the passage. Why do we know this? Because it says complement was used to discover the specific pairing. That's the word specific. And thus one chain, as it were, would be the complement of the other. And what solidifies D as the answer is how is this useful? It is used so that molecules can duplicate themselves. Duplicate and replicate is the same thing. So that makes D the correct answer. A, B, and C are out. All right, moving on to the next question. Question 28. Based on the table in the passage, which choice gives the correct percentages of purines in yeast DNA? Once again, based on the passage and the table, which choice gives the correct percentages of the purines in yeast DNA? So that tells us where to look in this table. We are looking at yeast, this row right here, and we are focusing on purines. And purines are which ones? We annotated which ones are purines. Let's go back to our annotation. Purines are the adenine and the guanine, A and G. So we're looking at the greens right here, these two, 18.7 and 17.1. So which choice contains those? We can see that this is choice A. So that makes A the right answer, and we can move on to the next question, question 29. All right. Let's read. Do the data in the table support the author's proposed pairing of bases in DNA? Do the data in the table support the author's proposed pairing of bases in the DNA? Well, let's have a look. We want to go through the choices here because we really don't know what we're looking for, so we cannot really use the my answer here. So let's just go for it. Choice A says, yes, because for each given organism, the percentage of adenine is closest to the percentage of thymine, and the percentage of guanine is closest to the percentage of cytosine. So they're saying adenine is closest to thymine, and guanine is closest to cytosine. So the pairings are correct, A and T, G and C, but are the percentages right? So we got to go to the table and see if that's true or not. So let's have a look. Adenine at 26.8, 27.2, those are pretty close. For humans, 29.3 and 30, pretty close. For E. coli, 24.7 and 23.6, those are pretty close. Let's look at the other pairs. We've got 22.0 and 21.6 for chicken, 17.7 and 17.3. So yes, we can agree that those pairings are making sense with what the passage said. So that the pairings are right, and the percentages for adenine and thymine are close to each other, and the percentages for guanine and cytosine are close to each other. So we already know that A is the answer, but just for the sake of proving these other answers wrong, let's read it. Let's read B. Yes, because for each given organism, the percentage of adenine is closest to the percentage of guanine. Well, that's not true. We've proven it. Adenine is 33 for octopus and 17.6. That's not accurate. So B would be automatically out. And then if this question is asking does the data support the author's proposed pairings? Yeah, we've already said yes. So these answers that start with no don't make any sense. There's no point of going over them at all. And with that said, we can go to the next question, question 30. According to the table, which of the following pairs of base percentages in sea urchin DNA provides evidence in support of the answer to the previous question? So, according to this table, which of the following pairs of base percentages in sea urchin DNA? So we're looking at sea urchin. Sea urchin is this row right here. And which answer is offering evidence to support the claim from the previous question? Remember, the previous question, we proved that the percentages are close to each other. So what we are looking for in this is either have the 17s, because those are close to each other, or have the 32s closer to each other. So whichever one shows up in the choices is what we need to go with. All right. So according to the table, which of the following pairs of base percentages in sea urchin DNA provides evidence in support of the answer to the previous question? We're looking for 17s close together. That is A, and that makes A the answer to question 30. Had we had the 32.8 instead of that, the 32.8 and the 32.1, we would have gone with that, but that does not show up. So go on. Question 31. Based on the table, is the percentage of adenine in each organism's DNA the same, or does it vary? Okay, so that's an easy one to figure out because we can just look at adenine, this column. Are those numbers all the same? No, they're not the same. They vary, don't they? That means we can eliminate some of these answers because the first two say the same, and C and D says it varies. So based on our knowledge and what we've seen from the table, they are not the same. They are varying. The question is, which statement made by the authors is most consistent with that data? So yeah, we know it's either C or D, but what statement is most consistent with this data? Let's go and look at this one, line 36 through 38. Adenine, for example, can occur on either chain, but when it does, its partner on the other chain must always be thymine. Well, that mentions nothing about variability, so I don't think C is it, but just for the sake of proving this fully well, let's read the following lines, 41 through 45 for choice D. It follows that in a long molecule, many different permutations are possible. That's variation, and it is therefore seems likely that the precise sequence of bases is the code which carries the genetic information. Yes, so many different permutations, that's variation. So we know for a fact that now D would be the correct answer to question 31. And that concludes this passage. So next we will be going over passage number 4 of test number 1. Congratulations, you've done a good job. I hope that you have learned even more about how to annotate, and number 2, how to use my answer. So also relish and enjoy the fact that science passages are generally shorter than those other passages we've seen before. With that said, we are going to end here, and I will see you in the next lesson where we'll be going over passage 4 of test number 1. See you there.